welcome back. From this video, we move to this OpenSCAD part within 10 project. The number 9 is called the Parabolic Reflector. So it's a nice, like a certain antenna for the satellite. And what we are going to add some idea for practice is using the 3D shape polyhedron, which we haven't used this before, but we have tried this on the 2D shape polygon in the project 3. That is there is 3D, the implementation. So let's start to do that. So first, let's open your SCAD. And we are going to have our file put in here in number 9 now. So we'll call that is number 9 parabolic. It's the numbers of the description in the text, which I suggest you can read that thoroughly. That has some mathematical background for those. To make those, we need to use this 3D the way to build this 3D shape and convert that to this parabolic and make that can be reflect. So as the background for this shape, we need to understand the characteristics of the parabola. Parabola is by fact is that all points on the parabolic surface on that surface has the same distance to a reference point, reference surface, or base surface, and a focal point. So that way is you can receive the signal and put that into this focal point. So that is the way is we have this base. So if we remember, we have some this calculation in this the rectangle formula. So cosine alpha is adjacent divided by hypotenuse. It follows the large if we have this angle is the alpha, then this are this edge divided by this edge. So that's the thing is we can start to put some mathematics this background or the preparation put into our code. So F and B. Distance between that is distance FB equal to norm F minus B. So if you want to see some basic things, you can come to the cheat sheet and search norm. So norm is the return the Euclidean norm of a vector. So not this return the actual numeric length, where len return the number of elements in the vector of degree. So those are, so if we see norm A is this Euclidean norm. So what's this Euclidean norm is you can see from more discussion. So those are the mathematics, the description for those. We use this formula, and this cosine A is equal to F dot Z is this dot Z divided by distance FP. And then also you can have this equal to dist FB divided by 2. So it's the distance divided by P dot Z. So P dot Z is here, and this is the FZ minus BC. So for the small triangle, so that is the formula. So since it's the same alpha in both cases, we can set the two ratios are equal and rearrange them to find the PZ. PZ is here. So this is what we want to find. And then there's some the formulas put in here. So I just copy this into our first code. Then we will leave this as some background. So let me save this and put those in the comments, because there's not able to run for those. So let me put those, edit comments. So all those are comments now. So we just put this at the bottom. So static background. And let's start to make actual drawing from the number 2. So you can have this one. So I will put this here. Yeah, let's make this function. So we have the parabola points function. So this function have two parameters. One is focus point and another is base point. They need to calculate based on these two. Then we have our base equal to. So equal to what is we will have a let distance FB equal to no focus point, that's the condition, minus the base point. After this we have our function, so we don't need this curly braces. So our function is based on this base point dot x, that is 1, base point dot y, and then the third one is distance FB times distance FB is just powered by 2 divided by 2 times focus point dot z minus base point dot z. This is our first part. So base point dot x. What's the arrow? Let's see. Syntax arrow in line. Let's see what's the syntax. Maybe it's, oh yeah, focus. So that is 1 focus base point dot z is base point dot x. Let distance, oh yeah, I miss one the closing parenthesis. So now that is our first function. So let's save to another one. After these parameters, we can start with the definition of our module parabola and calculate point on the surface of the parabola with the help of our function with this one, parabola point. So we have that parabola point here. So let's put in our starting comments. We define some key parameter. So one is the focus point. Is the focus point at the 3D vector. Base area will be the dimension of the base RS of 2D. And the resolution is number of grid point as 2D vector. So one 3D and two 2D vector. So what we will have, we will need to start to build our module and put our function inside the module. Parabola. For our module, we have a focus point, base area, and the resolution. Resolution we put is 10. And this will include our function. So can save on this. Then we will call our module parabola. When we call, we will give the enough the parameter. So we already have the default parameter for resolution. So resolution. So we don't need to make that again. So we have a focus point. Need to give our vector 75, 75, 100, and we need to give a base area, which we will convert that to 3D later. Now it's 2D. So we can have this. So variable AREE is not specified, so AREA. Okay, so far we don't have any error. Let's starting to build this. Our function is still keep same here, and after the function, we will start to use the things. Is we have this parabola points. So we need multiple points equal to our vector, and this vector we will define by a for loop. So we have this for loop. So like what I do is just put this pair for all of your parentheses. Then you can try to prevent to forget about one of that. That's most of the time is the reason for some errors. So y is from 0, base area dot y, resolution dot y, this as the step, and base area dot y plus 0.1, that is y. We will copy this and to make x. This was the difference. X is base area with x, resolution x, and the base area x. And after we made this for, we will put our function here. Parabola point. So notice here is the points, here is a point. So point, we have two parameters. One is the focus point. Secondly is the base point. This base point we will use xy, which will be changed. And we will put that on the z is 0. So let's have a try to see what is drawing so far. No error. That's good. because we have nothing putting in these shapes. So let's continue, save to another version, so 04. We have our the initial, the module on hand, and then it's since we need to create a 3-dimensional body, we need the point of base surface itself. We also able to create this with a generative for loop. Instead of using a function like parabola point, we can specify 3-dimensional vector for the points directly, and then this can be consist only the x, y, and the coordinate constant z. So now z is we are putting on 0. So that is what we have done. And then we have continue. So after we have those parabola points here, we will make the base points. So it looks like there's also similar for this. Let's copy our parabola points part. So let's see here is base area y, resolution y, base area y plus this, and base area x, resolution x, base area x. So the difference is for the base point, we don't have these parabola points. We just use x by 0 and have this semicolon. No arrow, that's good. For this snapshot, we will go to number 5. We have some tricky part now. We have to explicitly specify individual surface of our geometry. Each individual surface needs 4 points, surface I mean, which have to be specified in order. This is basically like trying to trace the outer edge of the surface with a pencil all the way through without starting over. So if you read these, the points in our array, parabola points, and the base points lie one after another as a long list. Each of these lists contains this one, the points, numbers of the point, resolution x, resolution y, plus 1, and make that product multiply. Thus, you can identify each point with a number. So we make that like our array, and with this house number of the points, we can now describe a single surface by combining 4 house number in 4 dimensions. So it's also like you're putting some 3D shape with by numbers of this triangle. So if you look at some gaming programming is using the triangle on the 3D space, you can build or complex the 3D shapes. So let's continue on this one. So after this base point, we are having the continue size dot underscore x. Let's do this resolution dot x plus 1, and the parabola faces. We use those 4 points per face. So that is our vector. We have first is the for loop. For this, then we go to our 4 points vector. So let's define this 4. Y from 0 to resolution dot y minus 1. Step by default it will be 1. X equal to 0. resolution.x. You see, sometimes I take some the additional effort, try to make this looks aligned on the different line. That's just our style for yourself. Also try to familiar is that can make your code clean first, but the big advantage is will be easier for you to use your eye to look at some errors. So that's fully depends on you. So how you can keep your code is more readable. So we have 4 points. So one is the size y times size x plus x. Second is just on x plus 1. Continue, we have one step for y times size x plus x plus 1. Then last is y plus 1 times size x and plus x. So that is what we have done. So what we have put in is you can consider that in this 2D dimension is we have defined our parabola point row by row. So from x, then we are then second is plus 6, then you have another 6 point. So that is our current preparation. And then for the continue for the surface of the base, we can proceed in the similar way. So this is the parabola face, and also we have our base face. So we will have size x is keep on that, and we also will define size PP points. Use the parabola points, and then we have a base face equal to this. We will have this to here, and we have a 4. This 4 is the same. X resolution y is resolution x, and then we have this. Let's also copy this and try to reuse y times size x plus x. Then we have for the plus size PP points. Just adding all these in the end. So size PP points. So syntax on this one, we have some arrows. Here, size is length. Parabola points here, size PP points, 4. So here, sorry. Okay, that's done. So we have now all defined the surface of a parabola and the base, and before continue, let's stop here first for this first part of the video. See you in the next part.